Hey guys, what's up? Today I have come up with new tutorial on NumPy. So stay tuned with me and enjoy the journey. So guys, NumPy is nothing but numerical Python which stores data in efficient manner and saves space, which in turn saves money as well. So having a ready-made function available, it can store data as per the flexibility of users and therefore it is fast as well. So without any delay, I'll come to code so that I'll tell you how it saves data. So open your VS Code and you write pip install NumPy. If you have not installed it, you can install it using pip. So I have already done it, so I need not do it again. I'll just show you. You write NumPy. I will show you that requirement already satisfied. Alright, so then you open your Jupyter notebook and it will start a server for you. Alright, then go to new and open a Python 3 file. So this opened a new notebook for you. Now I'll show you how this NumPy array takes lesser amount of data and take lesser amount of storage and gives a very efficient way to store anything. So let's say first I make a Python array py_ar. Let's say a list of 1, 22, 3, 11. Okay. Before this you have to import your NumPy. Import NumPy as np. Alright. So py array equals to 1, 22, 3 and 4. Make another NumPy array as np ar equals to the formula is there np dot array and pyar. Same with the same file I have done it. Okay. Now I have to check the size of both pyar and numpyar. So this I could have told you in the end, but I'll tell you how this NumPy array is derived, how this Python array is derived, but just show you how it takes lesser amount of storage. So let's say I run it, nothing has happened. Now I have to check the size. So what I'll do, I'll go import sys. Okay. Now after importing sys, there is an attribute called sys dot get size. Alright, so size of one element, and then when you get the size of one element, multiply it with the length of, that is length of the array. So you write pyar. Okay, so when you run it, something I have done wrong. So sys dot get size, oh sorry, this says sys dot get size of 1, and then you run it. You see, this is 112 bytes it is taking. This Python is taking 112 bytes. Now the same thing I'll check for the NumPy array. So I'll write np dot ar. Alright, the attribute is item size. Alright, multiplied by the size of one array, np underscore ar dot size. So you see when you run it, np underscore ar dot item size, and then you see 32. So there is a huge difference between the storage area. So it takes only 32 bytes and it is taking 112 bytes. So that is all I wanted to show you, that NumPy array takes a very less amount of storage device and thus saving the costs also. Alright. Coming to formation of array, how you can take an array, how you can define an array. So I have already done import NumPy np, then you define my array arr equals to np dot array, and then you give a list. So let's say 2, 23, 34, 55, 98, and when I'll write my arr, then it will give me a NumPy array, the array of, this is one dimensional array. Alright guys, so it gives the flexibility of memory management over here. So NumPy is a very important aspects in data science. It gives you a memory management flexibility, and you can define n number of arrays through it. So also you can define how much storage it should take. Then you define it as, if I want to store it in a, let's say, int 8, the integer 8, so I'll write np dot int 8, and when I run it, so data is int 8 type. The size of this array would be something else, and if I write int 64 and then run, then the size of this one will be something else. So it depends on the user, and therefore it is providing the flexibility to user to use the array. So if you want to access some of the elements, then you just simply write my array, and you give zeroth, at zeroth index, what is the value of your array. So you run it, it will give you 2. So this starts with 0, then it comes to 1, then it comes to 2 and 3, like that. Alright, so I'll just zoom in for you. Okay, then you want to change the array value to something, then that also you can do it. Then my arr, and you write first element, that is the index first, you want it as instead of 34 you want 39. Alright, and then print my arr, then see the result. So it has changed to 34 to 39. This way you can change the array also. Alright, you can change any number out of it. Alright, so now if you want to write something like my arr, alright, and 0,1, you want to see what is there in this my arr. So this will throw you an error, because here you have used 2-dimensional array, and whereas my dimension is only 1 over here. So if I change my array to 2-dimensional, so what I will do, I'll just write another big bracket over here, and then it changes to 2 dimension. Alright, and then if I have to run this, and then if I write my array 0,1, then what it will come, you see, it has come to 34, 55 and 98. This is my array. You want to see my AR 0,1, that also you can see, that is 34. So here is the 34, 0 and 1 first. So this is how you can define. You can define it in 1 dimension, 2 dimensional, 3 dimensional, and so on and so forth. Depends on the complexity of problem you are having. All right. So okay, so if you want to see the data type, then you can write a dot d type. I will tell you what kind of data it is. It is int 64, it has integer 64, it has stored it in integer 64 form. So like that you can see the shape also, my arr dot shape. I'll just zoom it. Okay, when you write my arr dot shape, and it is, and you run it, is 4 cross, that is it's a 1-dimensional array. So 4 into 1 is the shape of this. Then we also have list array. So like list array, and goes to np dot array, and you can give a list. All right, so I will make 2-dimensional one, 1, 2, 3, then 33, 2, 12, and you take 5, 4, 3. All right. So now when you write list array, you see what it will do. Oh, I'm sorry. You see, yeah. So it has given you an array matrix. It has given you, so 1, 2, 3, 33, 2, 12, 5, 4 and 3, like that. So now similar way you can see the list list array size dot size. It will tell you the size, that is 9. The size tells the entire number of elements available in the matrix. Then list array dot shape, and shape will tell you 3 cross 3. So this is 3 cross 3 matrix. And we can also make numpy array using intrinsic numpy array creation object. I'll tell you how you can do it. So this is nothing but a kind of function. So let's say zeros equals to np dot zeros, and it's a 2, 5. So, and when I write zeros, and run it, let's see, it has given me 2 rows and 5 columns, an array of zeros which consists of 2 rows and 5 columns. And like that you can make there are many functions in NumPy. So then if you check the type of data of this, then you see it will be given a float type, zeros dot d type, and it will give you a float 64. All right, so like that you have function. Then we have range function. So let's say rng equals to np dot arange, and you write let's say 8. Okay, and then you write rng, and you see what happens. Run it. It has given an array of 0 to 1 dimensional array, basically 0 to 7. So this is a range function. If I write 81, then it will give me a 0 to 80. So basically it will give me a 0 to an array of containing of 0 to 80, and like that. Then we have linspace function, which is linearly spaced function. So let's say linspace as L space equals to numpy dot array, numpy dot linspace, and linspace, in linspace you write 1 comma let's say 5, and between 1 to 5 you want 10 linearly spaced items. So it will, what it will do, it will provide you 10 linearly spaced item, okay, between 1 to 5. So if you run it, you see, you L space, and then you run it, you see it has given you 10 linearly spaced item between 1 to 5. So 1 point something, 1.4, 1.8, 2.3, these all are linearly spaced. That means it is equally spaced between each other. You can give 5 also. So it will give you, you give 5, then if you, it will give 1, 2, 3, 4, 5. So these are linearly spaced. So this is all about the linspace item, guys. Okay. Then guys, we have now we have identity also. So let's say IDE equals to, this is identity function, numpy dot identity, okay, and 45. So it will give me a matrix of 45 cross 45. When I write IDE, you see it will give me a matrix of 45 cross 45. The other space, that means these are 45 in number columns and 45 in number rows are there. Alright, so this is all about the identity matrix. If you have familiar with the mathematical concepts of identity matrix, it is easy for you to understand that way. Then we also have another function, like let's say array. If you want arr equals to np dot arr arange, arange and 99, okay, and when you write arr, then it will give you 0 to 98, the one dimensional array, the similar to this one, arange function. So this is also like that. Now this is a one dimensional array of 1 cross 99. All right, so I can also create this particular entire this thing into a matrix of 3 cross 33 also, or 33 cross 3. It depends on me. So for that we have a function called reshape. So if I write ARR equals to ARR dot reshape, and which matrix you want, 3 cross 33, and then you type and then you run this ARR, you see 33 cross 33, 3 cross 33 matrix it has given you. You want 33 cross 3, it will give you 33 cross 3, and then ARR and run it. You see 33, this has 33 cross 3 matrix. Alright guys, so let's say if you want to make it 33 cross 4, what will be the answer? I want you to do a comment in my comment section and write your answer, and I'll wait for it. Alright guys, I hope you would have commented on that. So if I write it like that and see what happens, it is throwing me an error. It is saying that it is not possible to make a matrix of 33 cross 4 out of this thing, because this is 99. Now 33 cross 4 could have been possible if, let's say, if it could have been 112. Alright, 33 into 132, I'm sorry, because 33 cross 4 is 132. Now it is possible. So if I run it, ARR.reshape, oh, no, I'm sorry, you have to change, you have to run this cell also, no? Now you run this, you see it has given you this thing. So it has given you an array of 33 cross 4. So this is another application of NumPy wherein you can change the matrix. Alright, now we have also ARR.ravel function. So what if I write ARR.ravel, alright, and then you run it, so it will arrange it in a simple way. So 0 1 2 3 sort कर देगा इसको. Alright, so it will sort it in this way. So this is a ravel function. So it will keep it in a one-dimensional array. Now very important thing over here is axis and rows. Guys, this is a very confusing one wherein people gets confused. So you just have to remember that axis is towards the rows, it is pointing towards the rows, and axis 1 is pointing towards all columns. So here two axes are being used, 0 axis and axis 1. So 0 axis is towards all rows, that is downward. If you see a matrix like if you see this matrix, okay, now in this way towards rows is axis 0. Alright, so this way is axis 0 and this way is axis 1. So like this you can make you can understand this, and while doing the problem you will come to know and it will be more clear to you. So let's say I have x equals to a two-dimensional array wherein I have taken a list of 1, 2, 3, then 4, 5, 6, and then 7, 1, 0. Okay, this is it. Now I'm making a NumPy array. So I will take AR equals to np dot array, and you write x. Okay, so when you type AR, it will print you an array of 2 dimension. So 1, 2, 3, 4, 5, 6 and 7, 1, 0. Now this is a matrix, guys. Now this is AR. Now AR, if I write AR dot sum, and I have told you that axis 0 and 1, So I write axis equals to 0. So what will be the answer? Comment it in comment section and let me know. Alright, so now ar.sum, if I do it, what it will do, this axis is towards 0 this way, so it will add 7 plus 4 plus 1, 5 plus 1 plus 2, 3 plus 6 plus 0, like that, and give you a one dimensional array. You want to see, you write, yes, you see 7 plus 4 plus 1, that is 12, 5, 2, 1, 8, 6 and 3, 9, so like that. Similarly, if I write axis equals to, I just copy this, axis equals to 1, so it will do some like, and I run it, you see 3 2 1 2 3 is 6, 4 5 9 6 15 7 1 8, so like that. So when axis is 0, it is counting towards the row sides. When axis is 1, it is counting towards the column sides. So this is very confusing, guys. Until unless you will solve the problem in this, you will not be able to understand. Alright, so now this is a matrix I have. If I want a transpose of the matrix, so I write ar.t is capital T, and you see when I do this, it will transpose it. Transpose in the sense the rows will become column, column will become rows. That is 1 2 3 will become rows, 4 5 6 rows will become column, second column, 7 1 0 rows will become third column. So this is nothing but a transpose of an array. Then also we have ar.flat is a function. If I do ar.flat and run it, it will give me an iterator. So I can use for loop in Python and iterate the item inside it. So I'll do it for item in ar.flat print item. So when I do it, it will give me the entire item inside this one. So I run it, you see 1 2 3 4 5 6 7 1 0. So all the items have been printed in this. Then if I want to see the dimension of the AR, then I write ar.dim ndim, and this will give me the dimension of the array. There is 2 dimensional, you see there's 2 brackets are there. Had it been 1 bracket or not here, yeah, here, had it been 1 bracket, it will give me 1 dimension. For example, if I write y equals to np dot array, and I give only one this thing 1 comma 2 comma 3, and then I write y, it gives me 1 dimension. Now y dot ndim, so what it will print? It will print 1. So 1 because this is 1 dimension. If I keep it under another bracket, then it will print me, and I run it, then it will print me 2. So this is all about the dimension, guys. And just delete this, not required. Okay. Then size I have already told you. Then number of bytes you can also find out, like ar dot n bytes, and it will give you a number of bytes. So 72 bytes storage it is taking. So guys, now let us make 1 dimensional array. Let's say 1 equals to np dot arange, np dot array, and 1 comma 3 comma 33, not big number, 5 comma 6 comma 8. Okay, so this is 1 dimensional array. So when I type 1 and run it, it will give me 1 dimensional array. Now there is another function called argmax, argmin and argsort. So what if I write 1 dot argmax. Okay, this is this parenthesis implies that this is a function. Okay, so when I do argmax, what it will do, it will give me the index of the highest number in the array. That means 8 is the highest number and the index of 8 is 0 1 2 3 4, so it will print 4. So I'll run it. You see it has printed 4. Similarly, argmin, I'll paste, so it should print 0. So if I run it, you see 0. Then we have argsort. So it will sort the item as per the index of lowest to highest. So 5 6 8, so it will print in the same way. So if I run it, 0 1 2 3 4, if let's say if I write 51 and I run it, okay, and then I put argsort, then you see the changes will be there. 0 1 3 4 2. So the 2 is having the 0 1 2, 2 is having the maximum this thing, and 0 is having the minimum value. So this is the argmin, argmax and argsort function. So NumPy provides the flexibility of matrix operation, that you can do perform the additions, subtractions, and you can do multiplications, and it is very easy to do that. Just make a NumPy array as AR equals to np dot array 1 2 3 2 4 5 2 9 8. Okay, okay, so it's a two-dimensional array. So when you write AR and run the cell, it will give you an array. Similarly, you write ARR equals to np dot array and 5 4 3, then 2 1 1, then 1 1 1. Okay, now when I print ARR, then it will give me a two-dimension. Now this AR and ARR subtraction you can perform, addition you can perform, multiplication you can perform. So if I write AR star ARR, and you see the result, that is 1 into 5 5, 2 into 4 8, 3 into 3 9. Similarly 2 into 2 4, 4 into 1 1, sorry 4, 5 into 1 5, 2 into 1 2, 9 into 1 9, and 8 into 1 8. So like that it has found the multiplication over here. Similarly you can perform AR plus ARR and will provide you the addition. You see the addition, you make the addition, it will give you. So 1 plus 5 is 6, 2 plus 2 is 4, 2 plus 1 is 3. So this it has performed, the addition it has performed. Similarly we can perform the subtraction, AR minus ARR, and will provide you the subtraction. So AR minus ARR is 5 minus 5 is, I'm sorry, this 1 minus 5 is minus 4, and so on. So you can perform this subtraction, addition and all. Then another function we have square root, AR dot sqrt, which ARR sqrt AR. Okay, so this will perform the square root. I'm sorry, this is np dot square root of AR, NumPy no. So it will perform similarly np dot square root of ARR. So it will provide you the square root of this matrix. This the square root of this one is this, and similarly you want to see, I'll just type here. So square root of 1 is 1. Okay, square root of 2 is 1.4, square root of 3 is 1.73. You also know square root of 3 is 9 is 3. So you can see. So this way you can perform the functions. So this is all about the numerical Python, guys. I have covered up most of the topic which is used in day-to-day coding, but there are n number of functions which are available in NumPy documentations, and you need not learn everything, but the only thing is that you should know from where to get the documentation from. So that is more than enough for you. So that was a sweet and short tutorial regarding numerical Python, and I see you in next video, guys. Till the time, take care, bye.